Statistic in R. So can you guys, Miss Moore, can you see the presentation? Can you see my PowerPoint slide?
I see your face more than
Okay.
your presentation.
Okay, let's see. How do I do that?
So I think you should probably block out your face.
Video.
Your video, yes.
Okay. Let's see. Stop video. Okay. It's good now?
No, you have to, what I would do is share your computer so that
Okay.
I could see it.
I believe that's what I did.
Yeah, because I only see, Sakina,
Yes?
I only see your, I can't see your presentation.
Okay,
Oh,
wait.
I see it now. I see it now. Okay, you can go
Okay.
ahead and start.
Okay. Okay, let's see. Good? You see now?
Yes, I see it. Yes.
Okay, perfect. Everyone, can I ask and see if anybody can is not able to see it, just let me know so that I'll see what to do. So again, my name is Sekina, and today we're going to be talking about time series plot and sample statistic in R. So I chose those two subjects because I feel like those are the good start for learning how to use R, and it has not only I'm gonna be talking about some code. It also give you a basic idea about how to do some statistical analysis by using R. So here is an overview of what we're going to be talking about. So my first few slides going to be talking about some basic, that is operator, creating new variable, building functions, and then we're going to move to an example where I'm going to be doing some analysis about in R and just giving you some comment on how to do some statistical analysis. So we're gonna be, I'm gonna talk about how to import data in R and then plots the closed price. So we're gonna be using like a data set. I'm will give you more information about it in the next slides. So, and then we're gonna plug a daily return, and then I'm gonna kind of give you how to use the for loop. I feel like for loop is very important when you're doing statistical analysis, especially when you wanna write down a formula in R. So we're gonna talk about for loop and the definition and all that in the following in the presentation, and then I'm gonna give some comment on how to plot an histogram, and then from that we're gonna just play with some sample mean and variance and just with those functions, and then we're gonna move to plot the return in percentage points, and then I try to bring it up because I wanted like everyone to see the difference between plotting the return in percentage points and then the return in log points. But most of the time in economics data analysis, we most of the time using the log return. So I'm just gonna give those two different strategy, and then yeah, that's gonna be the end. So this slide is for me to introduce myself. So thank you for being here. My name is Sekina Janchimo. I'm a student at Rogers University in New Brunswick. I'm part of Douglas Residential College. I'm in my senior year, majoring in economics and mathematics minor. Okay, I'm currently an intern at More Statistics Consulting LLC, and then the following link is my LinkedIn page, just in case if somebody wanna like connect or something like that. So yeah. So this is the kind of the start of our presentation, and then it's talking about operators, and I feel like those are like some basic things that you need to know about R, instead of sometimes using a calculator to do some addition or subtraction. I just want everyone to know that you can still use R to do whatever you want to do when it's come to computing some numbers. So we are going to be focusing on arithmetic operator and relational operator in R. However, there is more other operators in R, such as logical and piecewise operations. So here is, I just made a few two tables trying to just show you example of what I call operator relations operator relations, and then some descriptions. So we have less, greater than, less than or equal to, or greater than or equal to. So we have that on our left, and then on our right we have operator arithmetic that is, and its descriptions. We have plus, subtractions, and multiplication, division, and exponents. So this slide is kind of what you need to know, maybe like basic thing you need to know when you're starting doing R. So which is you have to know how to create a variable, which is what you're gonna be like kind of always time you're doing data analysis in R software. So you just need to use this operator as I talked in the previous slide, that's less than or less than equal, and to create a new variable. And this is a couple of examples that I gave. So this is a code of data sum, which is data sum x1 plus data sum equal data x1 plus data x2, and then you can also calculate your mean directly by using the sum of data x1 and then data x2 divided by 2, or like whatever you feel like you want to do using those operators. And then the dollar sign, I feel like it's important to mention that. That's gonna help you specify a column of data that you're going to be using. So for example, you will see I made data dollar sign x1. That means like I'm telling the R to go like in the x1 column to take those data. So that's kind of what the dollar sign stand for. So now here we're gonna be going over the built-in functions that I'm gonna be talking more about it in the next slide. So I just put it here so that we will just know like those are like some built-in function in R, and then there's more other functions that we could find in R, but in this presentation we just focus on mean, variance, and standard errors. So this is the example we're gonna be going through, which is here I'm using the SAP 500. The SAP 500, we're gonna be focusing on the close price. That's why I highlighted in red. So the data set is okay, yeah. So I save the data set as a SAP 500 CSV, and it's contain 1,259 observations. So you can open this file using Excel, and it contains 7 column of variables. So we have the dates, and then the price, beginning of time interval, and then we have high price in this time interval. We have lower price, and then we have close price, which is what we're going to be using in our presentation. And then we have adjusted close price, and then we have the volume, which is like we are not even going to be like going over that one. So this is how the data or the table look like when you open the Excel, or when you import the data in R, it's gonna be looking. This is what it's gonna be looking like. So so here we're going to start our analysis. So the step number 1 is to import the data into R. So I have saved the data as SCV. I have saved the data as CSV, sorry, in my R Studio working directory. Then I import the data into R using the following command. So yeah, those are the command that you can use to create or to import your data in R. So you just use R CSV SAP 500 or the name of your data set. So the step number 2, which I would say it's kind of a specific clue that I find important to highlight, especially when you're working in R. It's very important to see how your date are like your date format. So sometimes it's year, month, and day. That's how your R Studio gonna format it. At the same time, sometimes it can be month, day, and year. So it's for you to go or to open your data set and see how it's formatted, so that you'll be able to code it. So that's why I feel like it's important to remind everyone, just in case you're running out of some problem errors, you can try another format to see if it will work out. So the comment for that is dates as is AS dates, S&P 500 dates, and you will see, as I told you, the dollar sign is still there. That means we're using the dates, the column dates, and then we're using the format that is year, month, and day. So the third step is to plot our close price, which is kind of very straightforward. So all you have to do is here we're using our y-axis as S&P 500 and close price. You will see I still use the dollar sign close, and then you just plot. You just use the plot function. You put on your dates as your x, and then your S&P 500 close as your like your y, and then type 1, and you can change any type that you want. There's so many others kind of type, and here the type is stand for line, and then the main that's like the title of the plot, and I use S&P 500 index. You can use anything you want to name your title, and then the color is gonna be blue. So the following gonna be like the image of how it looks like when you run your code. So this is how it looks like. So yeah, we have our color, we have our x-axis, that is the dates, and then we have y-axis, that is the close price, and then yeah, our index is the S&P 500 index. So the next step gonna be the daily return using the log price. So this is kind of like interesting points that's I like to talk about. So after you create so we have to create a new variable, and then we have to use the log price. So for that is log S&P 500 close. That means you use your logarithm function for the close price. So you just create a new variable for that. So but here those are like just the next point is just basic idea of how we cannot like find we cannot calculate the return of the first year, because the return is equal to this the current year minus the previous year. Since at the first year we cannot have a return, so we try like to skip the first year. So this one is just about that. So here is we create our return, and the return variable, so we name it return is equal to rip 0 and length of the log price minus 1, as I explained above, because we cannot have the first return of the first year, so we have to subtract 1 from the length of log price here. So, and then this slide, it's just the general formula, just in case anybody forgot about the return formula using the logarithm functions. So so next here we're going to be talking about the for loop, which I feel like it's very important for us to learn that, especially when you're doing you're calculating the price or the returns. So the for loop I use in programming to repeat a specific block of code. Moreover, a for loop is used to iterate over a vector in R programming. So the syntax for the for loop is for the value in sequence, and then it's and then your statement. So a sequence is a vector, and then each of its value during the loop in each iteration statement is evaluated. So now that we know what the for loop means, so we're going to now use the for loop to be able to model our return. So we now write a for loop and assign date t+1 to return to the tth elements of the vector, that is return t. That's the vector we're using. Using our syntax of for loop, Yeah, if you remember in the previous slide, I gave you the syntax that is for the value in the second and the statement. So using that, we have the following code with our return vector created in previous slide. So here is the code for the for loop. So that means so for I is like the first variable for I in 2 to 1259, which is like the last variable that we're using. So then that means we're starting at day 2 instead of 1. So that means we're telling R to start from 2 to 1259. And then our return I minus 1, that means like the second, not the first day, but the next one, is equal to, is equal to log price I minus log price I minus 1. So if you remember, I gave you this formula of log price in the previous slide. So we just trying to put everything together by making sure that we're giving the software the right information so that it will formulate our formula like in the right way using the for loop syntax. Okay, here now we have like, since the for loop was the hardest part, since we get over that, so the rest is just using some function in R and try to figure out like what we want to do. So here we want to plot an histogram of return. So after we get all the return, let's plot the histogram with the following specification. So in this histogram, we're gonna have a break 100 frequency of 2 value, and then column gonna be blue. So and then the following code, this is the following code. So ist return break 100 frequency 2, and then column blue. So the break is giving the number of cells for the histogram. So that's what the break means. So here is how it looks like, and yeah, we have our color, and then we have our return on the x-axis, and then the frequency is on the y-axis. So so now the next is just to find the sample mean and then sample variance. Since we have a model of our return, all we have to do is to take mean return and then variance return. So like you just need to name your variable. So here I name it as simply mean of return, which is the mean function, and then I just plug in my return. So and remember that we create a vector for this return using the for loop in the previous slide. So all you have to do is to keep like doing, like now that you model the return, you just keep shaping whatever you want to do, try to see the trend in your data set, and whatever you feel comfortable doing with your data set. So now it's the simple variance of the return, and then I just put var function, which stands for variance, and then I add my return in parentheses, telling our function to go like find the variance of the return. So and then the standard error is just the square root of my variable of variance here. So yeah, that's like the general formula of standard deviation. Okay, so now here is like something I feel like I needed like to talk about, because sometimes when people hear about return, they think about, okay, current price minus previous price over previous price. But at the same time, most of the time in like economics field, we use the log return instead of just the percentage point return. And then I feel like it was important for me to mention that side, and then so that we all could see the difference between the previous plot and then the current plot in percentage point. So this plot is just the same as the previous one. It's just the same as the previous one, and except the fact that we didn't use the log return. So we just your date start from 2 to the length of dates. We create a variable dates in the previous slide, and then we have our return, which is our vector, And then the main is the title, which is S&P 500 return. And then the type is P. As I mentioned before, you can have any kind of type that you want. Before we use type 1. Type stand for the line. We use type 1 the previous one, but this one I chose to use type P. So that's why I highlighted in red so that everyone will see that I changed the type this time. So, and then the color, you can choose any color that you want. The X lab is stand for X axis, that is the date, and your your Y lab stand for your Y axis, that is the return in percentage point. So, and then I use the plots as I said before, it's the same thing. I just repeat as I just said. So here's the general formula for the percentage return, for the percentage point, sorry. And then, yeah, next is how it looks like. So this is kind of hard to tell exactly what is happening in the data set. So that's why I feel like that's why most of the time we use the log return, so that we will have exactly the idea of the trend of the data set. So there's also a demonstration, a mathematical demonstration behind these two method of calculating the return, and it's not going to be covered in this presentation. Okay, thank you so much. Anybody have a question? I think no, sorry, not yet. I need to give you a summary of what I've been talking about first. Okay, we went over how to do a time series plot and there's sample statistic in R. And then we create a new variable, and then we calculate the return in R by using the logarithm return that I talk a lot about it in this presentation. And then I plot the return and the histogram using the R code, and we use the return function to calculate the sample mean standard error. And then, yeah, I think that's all we talk about today. And then please, if you want to learn more about how programming, you can visit the morestats.com and then just to have more information. Thank you so much. Anybody has a question? Hello?
Hello.
Okay. Hello. Okay, good. I get scared.
Okay, Rachel.
I do not have a question.
Yeah.
What slide did you have a question about?
I do not have a question.
Oh, you did not. Okay.
Yeah.
Comment? Does anybody have a question or comment to make?
No, thank you very much.
Oh, okay. Thank you. So we'll just wait a few minutes, I guess, and see if anyone has a question or
no
comment.
Problem.
Yeah.
Okay.
Where are all of you from? So I see Rachel, Charlie. Charlie, are you there? So some people have their microphones muted. If you care to introduce yourself, please do so. I'm from New York. Sakina, where are you from?
I'm from Togo in West Africa.
Ah, okay, okay.
Yeah.
Okay, so we'll just sit. I see some other people. Oh, there's someone that has a chat comment.
Yeah. Oh,
will this presentation be available offline? Yes, it will be. Yes. But it's good if while you have the person available to you that you ask any questions that you have. Even if you came late, if you have a question, you should ask.